Hi everyone, let's talk about integration by parts. What we are given here is an antiderivative of a product of two functions. X is one function, cosine of x is another function. And we are asked to find the antiderivative of the product of these two functions. Integration by parts is a special method of integration that is often useful when two functions are multiplied together, as in the case of our given problem. We can think of integration by parts as an integral version of the product rule of differentiation. The English mathematician Brooke Taylor discovered this technique in 1715. He is the same mathematician who created the Taylor series, which we discussed in our other videos. But before we can solve this problem, we need to derive first this integration by parts formula. And here's the formula that we are going to derive. Let's begin by letting y equals the product of two functions. Our two functions here are u of x and v of x, and the product is y of x. Then let's get the derivative of both sides. So we have dy dx is equal to d of the product of u and v over dx. At the right side, we are asked to find the derivative of the product of the two functions u and v. So to get now the derivative of u times v, we apply the product rule of differentiation. So we have the first function times the derivative of the second function plus the second function v times the derivative of the first function u. Then we can subtract both sides of this equality by v du over dx, and by rearranging, we arrive at this new form. You have the first function times the derivative of the second function is equal to the derivative of the product of the two functions minus the second function times the derivative of the first function. Now let's concentrate on this initial result. Let's get the antiderivative of both sides of the equation. And so we arrive at this line. This part here is the antiderivative of this left side. This one is the antiderivative of the first term at the right side. And this second part is the antiderivative of the second term at the right side. Now let's focus on this part. Let's remember that the derivative of the product of the two functions u and v is the original derivative that we start with. And so if you let y be equal to the product of u and v, then if you now get the antiderivative of this part here, then we need to get also the antiderivative of the left side. But what is the antiderivative of the left side? The antiderivative of this is the original function that we differentiate, u times v. And so this portion here must be equal to the product of the two functions u, v. So let's do now the necessary substitution. So this part here is equal to uv. Just copy the left side, copy the right side, and copy the corresponding operations. This last part now here is what we call as the formula for integration by parts. So let's zoom out this formula now. The integral of a function times the derivative of another function is equal to the product of the two functions minus the antiderivative of the second function times the derivative of the first function. Let's apply this formula in our problem for today. Here is the problem that we are going to solve, and here is the formula for integration by parts. We need to identify the u, the dv over dx, the v, and the du over dx. Now we have here two functions. The first function is x, the second function is cosine of x. Technically, we can choose any of these two functions to be our u, and then the other factor here will be designated as our dv over dx. But we need to be careful in choosing our u, and the guideline is we will choose u so that the resulting integral is simpler than the original integral that we start with. So let's begin by letting u be our x. So we let this u be this x. If u is equal to x, then we can get du over dx is equal to 1. If we have chosen x to be our u, that implies that this cosine of x will be our dv over dx. So we now let dv over dx is equal to cosine of x. And to solve now for v, we need to get the antiderivative of both sides, and the antiderivative of cosine x dx is sine of x, and so v is equal to sine x. So we now know what's the value of u, that is this part. We now know the value of dv over dx, and that is this part. We know the value of v. The value of v is this part, and we know the value of du over dx, and that is this part. So we now know all the parts that we need in order to apply the integration by parts formula. And doing the necessary substitution, we now substitute x for u, We now substitute cosine x for dv over dx. We copy this dx. Then u is again equal to x. And v is equal to sine of x. Copy the minus sign. Copy the integral symbol. Then v is equal to sine of x again. Du over dx is equal to 1. And we copy dx. So it's just a straight substitution. Finally, we can now compute this right side. The antiderivative of sine of x is negative cosine x. And negative cosine of x times this negative sign here will result to positive cosine of x. And so we now have the antiderivative of x cosine x dx is now equal to x sine of x plus the integral of this part, which is cosine x plus the constant of integration c. And this is now our final answer. And we arrive at this using the technique which we call as integration by parts.